A galvanic cell made from aluminum, aluminum 3+, and zinc, zinc 2+ half cells will have the zinc, zinc 2+ half cell as its cathode, because zinc, zinc 2+ half cell has the more positive, or let's say less negative, E0 for its standard reduction potential. So when we want the half equations for the half reactions of this galvanic cell, we start with the zinc 2+ going to zinc solid reduction step. Because this is the reduction, that makes zinc the cathode. This is going to be the reduction because the standard reduction potential, the E0 of this reaction, again, is more positive or less negative than the aluminum 3+ to aluminum reduction. Therefore, aluminum will be forced to provide the electrons for the reduction of zinc 2+. So the aluminum solid must be oxidized. It gets oxidized to aluminum 3+. This makes zinc the anode in this particular galvanic cell. Again, the decision of which is the cathode and which is the anode is based upon a comparison of the two E0 values for the two half cells. If we want a balanced overall equation for the cell reaction, we need to combine the two half cell reactions. So again, we put down the zinc 2+ reduction and the aluminum oxidation. We're going to combine these to get the overall cell reaction, but it's important that electrons lost equal electrons gained in a balanced equation. So if 2 electrons are gained by zinc, 3 are lost by aluminum, we need to multiply the zinc equation by 3 and the aluminum equation by 2. This would result in 6 electrons gained by zinc 2+ and 6 electrons lost by aluminum. Once we put the multiplication in there, we simply add up the two half cell equations, noting that the electrons will cancel because we have correctly multiplied out so that electrons gained are equal to electrons lost. This is what we call a balanced overall cell equation. In the third part of the question, we are asked to calculate the standard cell potential. This simply makes use of the two standard half cell potentials for aluminum 3+ to aluminum and zinc 2+ to zinc. Because zinc 2+ to zinc reaction occurs as written, that E0 contribution will be simply the minus 0.76 volts. However, the aluminum equation will occur in reverse. It will occur as aluminum to aluminum 3+, and therefore its E0 contribution will be negative the reduction E0 potential. So it will be equal to minus 1.66 volts. And now, to get the overall cell potential, we simply add these two contributions. So we start with the contribution from the zinc 2+, minus 0.76 volts. We add the contribution from the aluminum to aluminum 3+, minus 1.66 volts. And then we look at the result. The result is a positive value. And this is important in verifying that we have chosen the correct electrode to be the cathode